Hi, friends. I'm sorry I can't be with you today, but I am out leading a workshop and I'm kind of here in spirit because you get to watch this video and I'm definitely just walking you through the notes we would have taken. So, first things first, you do have an optional currency assignment. You can do this with your team. Or if you don't do this with your team, then you just don't get currency. Like, no big deal. But I would like to know what you think if you're watching this. So take a second, pause this video, go enter your team's currency. After that, we're going to take some notes. So you definitely need to have a little bit of paper out. You might have to pause the video at some point to write some things down. But just, write down the important things. You don't have to copy questions, but at least make sure you write down like what I'm writing on the slides. So we are going to talk some about momentum today. We're going to take momentum notes, and then Miss Filler has given you a practice worksheet on momentum. You're going to do the front with those practice problems only. The back, that mini lab, we're going to skip that. We're not going to worry about that today. We'll do that next class when I'm back. And then since we had that lab last class on acceleration with the car and the ramp and the motion detector and also the tumble buggy, and we made the graphs, all those graphs, you're going to have an acceleration lab quiz on that. So you're welcome to use your lab on the lab quiz. It's on Canvas, and you have 5 tries to take that. So make sure you get that done today. Okay, so onto momentum. So if you think about momentum and how people use that word in everyday language, you probably think, okay, so momentum, we're talking about things that are moving. But let's look at this situation. We have a butterfly and a truck. Your first instinct is probably to say that the truck has more momentum. Now, you might be like, oh, this is a trick question. What is she asking? Is there something else to it? Well, yeah, there is. But why did you think that this truck has more momentum? So to really dive into that, we have to look at what is momentum. So momentum, hint, hint, write this down. Momentum measures how difficult it is to stop or to turn a moving object. Basically, to slow down and stop, or to change the velocity in some different direction of something that's already moving. So what kinds of characteristics, what kinds of properties, which properties of an object make it hard to stop or hard to turn? Well, if you're thinking back to that truck, the first thing you probably came up with is mass. More massive objects are more difficult to stop. If a truck is barreling toward you at like a certain speed, it's like flying down the road at you, you're not going to want to step in front of it. If a butterfly is flying at you at the same speed, you might not care. You might stand in front of that butterfly because it doesn't have much mass. So it's not as hard to stop moving at the same speed as that truck. But faster objects are also harder to stop. If you are playing catch with a 2-year-old versus if you're playing catch with a professional baseball pitcher, you might have the same baseball with the same mass, but when a 2-year-old child is throwing it at you, that's going to be fine to catch with no baseball glove on. But if a professional pitcher is throwing it at you, you probably don't want to stand in front of that with no baseball glove on. That's going to hurt your hand. You could be in some serious trouble because that high velocity is going to make it very difficult for your hand to stop that baseball. So the more velocity something has, the more momentum it has also, the more difficult it is to stop or to turn. So we have a formula for momentum. And yes, this formula is a little tricky. So momentum, the symbol is P. It is a lowercase p for momentum. So P, we've already used M for a variable. M stands for mass. We're not going to use that for momentum also. That just gets confusing. And then we know V stands for velocity. But we kind of reached back to some different languages. All of these scientific terms come from other languages, and we reached back to ancient Greek and looked at a different spelling, a different word for momentum that means the same thing, and it has a P in it. So we go with P for momentum. If you're not going to remember this, you can look it up on your physical science reference tables. It definitely says lowercase p equals momentum. So don't worry about memorizing that part. What you do need to memorize are the units for these things. So momentum equals mass times velocity. And mass, we know, is measured in kilograms. And velocity is measured in meters per second. Now, when I calculate momentum, I'm multiplying mass times velocity. So I'm multiplying kilograms times meters per second. That means the units for momentum are just kilograms times meters per second. Sometimes you'll see a little dot in between the two. Sometimes you won't. You'll just see a space. But it's just those two units multiplied together. So yes, this is all a little different. It's a little weird. It's not quite as simple and straightforward. Momentum is P. The word doesn't have a P in it. You're just going to have to know to look that up. All right, so now that we learned a new formula, we're going to try a practice problem. So we have a bus. It's traveling at a velocity of 3 meters per second. That means V equals 3 meters per second, m/s. Then, continuing reading the problem, if the bus has a mass of 12,000 kilograms, so that means m equals 12,000 kg, kilograms. It asks us, what is the momentum of the bus? So we're looking for P. We're looking for momentum here. So to calculate momentum, we know V is 3 meters per second. M is 12,000. This is a pretty massive bus. Kilograms. We want P. We're going to look for our formula that has P and M and V. And it's that one we just learned. We can look it up on our reference tables. P equals M times V. So we don't know P. We can leave the symbol P where it is. But for M, we're going to plug in that 12,000 that we got for M. So I write 12,000 kilograms here. Then for V, we're going to plug in this 3 meters per second, 3 m/s. So to find P, I'm just multiplying the two. So 3, if you plug this in your calculator, if you need to, go right ahead. But 12,000 times 3 is 36,000. And if you remember from what we just said about the units, we just multiply the units together to get momentum units. So we had kilograms times meters per second. We just write kg times m/s. And that's our answer. We're done. That's the momentum. So let's see if we can solve a different sort of problem with the same equation. So we're in the Hunger Games now, and we have Katniss, and she shoots a bow and arrow because she's amazing at it. And her arrow, Katniss fires an arrow with a mass of 2.0 kilograms. So we know M equals 2.0 kg. And we also know that this arrow has a momentum of 130 kilogram meters per second. So that's P. We know that because it says momentum here, and we know it because of these units, kg m/s. Whenever you see those units multiplied together, kg and m/s, that is a momentum unit. So we're going to write that down. And the question asks us, what is the velocity of the arrow? So we're looking for v. We don't know what v is. So we're going to go through and use our givens, use this given information, and plug them in to our formula to solve it for v instead. So we have P equals m times v. We do know P this time. It's 130. Oh gosh. Sorry, I don't know, my pen jumped. I don't know why it does this weird stuff. Ooh, goodness gracious. Okay, so 130 kg m/s equals, we know m is 2.0 kg, kilograms. What we don't know is v, so that's what we're trying to find. Now, if we want to find v, and v is being multiplied by this 2.0 kg, 2.0 kilograms, we've got to undo that multiplication. The way we undo multiplication is with division. So we divide both sides by 2 kilograms. That means on the right side of our equation, 2 divided by 2, those cancel out. And we're left to find velocity on the left side of our equation. V equals 130 kg m/s divided by 2 kg. So 130 divided by 2, if you want to plug that in your calculator, it's absolutely fine. But we should get 65 for the number. And then the kgs actually cancel out to leave us with meters per second. And we know that that is a velocity unit. So, oh gosh, what is up with my screen here? So we are good once we found velocity. All right, so if we go back to this, which has more momentum, the butterfly or the truck? Well, yes, it depends on mass. So if they're moving at the same speed, then the truck would have more momentum because it has this high mass. But if the butterfly had a higher velocity, like let's say if velocity is 0 for the truck, the butterfly has more momentum because if the truck isn't moving, it has no momentum. So if the butterfly has a very high speed and a low mass, it can still have the same momentum as the truck, or it could even have more momentum as the truck. So even though the truck has much more mass, it probably, if they're both moving, it would probably have more momentum. But there is a chance that the butterfly could have more if its velocity is much higher than the truck's velocity. So now your assignment, you are going to do the momentum practice, the front of that page, not the lab on the back. You'll need to do the acceleration lab quiz from last class. It is on Canvas. You should have the motion graphs that we were doing for those drivers A and B last week, so you can keep working on those. And if you get everything done, then you can do the momentum quiz on Canvas if you feel confident with this. Next class, we're going to do the momentum quiz, and you're going to have more time to work on that study guide practice test. And then the class after that, we're going to take our first test on motion. All right, so again, message me if you have any questions. I do miss you. I wish I could be there, but I'm trying to make other teachers in the county as, you know, caring and awesome as I try to be. And I'm trying to make them realize that all of you guys are the best. So I miss you. I will see you soon. Please do your work. Do a great job. Love you. Bye.